In 6.3 we talked about factoring x squared plus bx plus c. So basically it's a special case of this right here, because we said that a is equal to 1, so we had x squared plus bx plus c. But what if a is not equal to 1? What if we have something in front of the x squared? So say, for example, what if we have, let's say 6x squared plus x minus 2. Well, what if we need to factor this out? This could possibly be the result of some mx plus n times p x plus q. See, when you multiply all this out, you'll get something that looks kind of like this. I mean, it won't look exactly like this because you have m's and n's and p's and q's here, but it will. When you multiply this out, you'll get something where a is not equal to 1. Where you get something that looks like this, but a is not equal to 1. So, if we want to find out how to factor this ax squared plus bx plus c into mx plus n times px plus q, once again, since factoring is basically reverse distribution, we need to go ahead and do this in reverse. So we want to go backwards and see what tricks we can find to go back. So that means we have, say, mx plus n times px plus q. So let's go ahead and multiply this out and see what kind of results we get. So we have mx times px will give us mp x squared. So mpx squared, because we have mx times px, m times p times x squared. And then mx times q, so that'll give us mqx, and then n times px, so we'll have npx, and then n times q, so nq. So this is going to be most of the way there. So after that, we want to go ahead and multiply this. Not multiply, sorry. We want to combine like terms here, so we'll have mpx squared plus mq plus np all times x plus nq. So here, let's clear that off. So all I did here was I combined these two like terms. Let's see if I can add some space this time. Okay. Added some space. Let's add. I want to try to get this under this. Almost there. Okay. I just want to get this underneath it. So all I did here was I combined these two terms to get mq plus np all times x. So we want to find out how this might be equal. How can we factor ax squared plus bx plus c into mx plus n times px plus q? Well, here we have ax squared plus bx plus c. Like, this is the a, this is the b, this is the c. So this is equal to ax squared plus bx plus c. We need to find out how to connect this to the a, this to the b, and this to the c. So we want to find m, n, p, and q such that, here, let's clear all that off, such that and MP equals A, NQ equals C, and MQ plus NP equals B. Okay, so we want to find M, N, Q, and P such that M times P equals A, N times Q equals C, and MQ plus NP equals B. Now that probably looks very daunting at first. The thing is, all you really do is you just guess and check, ultimately. So let's use something, an example that's a little bit more concrete. Let's use the example I used before. So, let's say, for example, 6x squared plus x minus 2. 6x squared plus x minus 2. So one thing that we can kind of see is that whenever we put this in the form something times x plus something, we can see there's going to be a plus in one of the binomials and a minus in the other. And the reason why is because of this right here. Because these later terms need to multiply to make a negative number. But let's not deal with that right now. Let's just talk about this more generically, about these MPs and stuff right here. So we know that MP needs to multiply together to make A, or 6. And NQ need to multiply together. I should do this over here. So let's clear that off and do it over here. Just for the sake of room, I'm going to run out of room if I don't do that. So MP needs to make 6. And NQ needs to make negative 2. Because this is A, and MP equals A, and NQ equals negative 2 because negative 2 is C. So now we need to find, well, let's go on to the next part. MQ, M times Q plus N times P will need to equal 1, because there's an implied 1 here. So we need to find these numbers, and really the probably most straightforward and easiest way, not the shortest way, but the easiest way, is to just make some guesses and check to see if they work. So let's say we need to figure out what two numbers multiply together to make 6. Well, we can have 2 and 3. So let's erase that. Just say we'll guess. This is one guess. M equals 2 and P equals 3. Another guess for N and Q, so we'll say that N equals 1 and Q equals negative 2. This is just a guess because we do know that N times Q will equal negative 2. Now let's go ahead and add these together and see how it works out. So we'll have 2 times negative 2, because M times Q plus N times P. N is 1, P is 3, N times P. So this will equal negative 4 plus 3 equals negative 1. So that means, see, is this equal to B? Well, B is an implied 1. This is negative 1. So that means that this did not work. It's pretty important to understand that your first try is probably not going to work. That's just kind of the way it works, because this is kind of complicated stuff. So I want to clear this off a little bit. Now let's try, but since this was negative 1, see, we had a negative here. Since this was just the opposite of what we wanted, I'm going to try switching these two signs. So let's instead try M equals 2, P equals 3. So those two things stayed the same. And we'll try N is equal to negative 1. Here, let's make that a little bit more clear as an N. And Q is equal to positive 2. So once again, these two things will multiply together to make positive 6. 2 times 3 is 6. These two things will multiply together to make negative 2, and that's what we want according to this. Now let's try adding them together and seeing if it works. So we'll have 2 times 2 plus negative 1 times 3, excuse me, negative 1 times 3, n times p. And that's going to equal 2 times 2 is going to be 4. And then negative 1 times 3 is going to be minus 3. That's going to be 1. And that's what we want. So that means that these are the right variables. But of course, just because they're the right variables doesn't mean that we're done with the problem, because we still need to go ahead and write this out in this way. So let's say, here, let's move this up a little bit so we'll have some more room. Yeah, okay, so we want, okay, here's what we want. Okay, so, wait, is that? No, this is what we want, excuse me. So, we want to use this. We know what mx and n and p and q are, so now we can rewrite this entire thing using that. So, we know that we have mx plus n, so m is going to be 2, x plus n is going to be negative 1. So this is the first part, mx plus n, because m is 2, n is negative 1, then times px plus q. P is going to be 3, and q is going to be 2. So 2x minus 1 times 3x plus 2. That might be kind of strange at first, so I would suggest working through these kinds of problems as practice, because these are kind of strange problems. But now that we have this, down, we can go ahead and double check it. And it's good practice to double check it. So let's go ahead and double check this by distributing. So we have 2x minus 1 times 3x plus 2. 2x times 3x is going to give you 6x squared. And then 2x times 2 is going to give you plus 4x. And then negative 1x times 3x is going to give you minus 3x. And then negative 1 times 2 is going to give you negative 2. Combine like terms, we'll get 6x squared plus x minus 2. And notice that this is the same thing that we got here. So that means that this is going to be our final answer. Alright. Examples are the best way, I think, of seeing the way guess and check works. So I'll be doing another example video. Then after guess and check, we will do a different method called grouping. Alright, I will see you for the examples.